Okay. So you say a quick word. I believe I sent you a Canvas announcement about the Math Jam. CSM has a Math Jam right after the New Year. I think it's January 4th through 8th. It's the first full week of 2021. So if you want more information on it, it's there. It's a good way to get a head start on the next semester. Yes, I know it cuts down on your vacation and everything. Of course, we all know that. So it's optional. You don't have to do it if you don't want to, but if you want to get a nice head start to spring 2021 semester, then that's what Math Jam is about. So it's up to you if you want to look at it or not. Okay. And let's see. So all we have really is 4.8. I might very well knock it all off today. Okay. In which case, you have tomorrow and you have Thursday for questions and answers. Wednesday holiday, school holiday for Veterans Day, so no classes Wednesday, of course. So it's another one of those, I like to call them one-day weekends, which is nice. Okay, so our next exam is Friday. Okay, usual rules. So let me just blab again, but I repeat myself so that nobody can say, "Oh, I didn't know what the rules were," because I say it over and over and over, right? Okay, so you know what to turn in. This is the homework. You have to submit at least 70% of the homework. I end up doing a huge percentage, so it's not really 70%. I end up doing a lot. Sometimes I end up doing an entire homework section or half of it, or even if it's one third, that's a lot fewer problems that you have to do on your own. So you submit all this stuff. That's what you're responsible for. Okay, so again, I'll try to dedicate Thursday for Q&A, but maybe even tomorrow. Depends how far I finish today's stuff. Okay, and Friday around what we start at 12:10. I'll try around 12:01, 12:02. I'll send via Canvas announcements the exam, but I'll also project it. For some of you, it's better for me to just project it. You can have your cheat sheet. Start filling out your cheat sheet front and back. Um, have your camera on, but yourself should be muted. If you have questions during the test, send to me via the chat. And what else? If you finish early, of course, you can leave early. And so I will close the meeting as usual at 1 o'clock, at which point you have 5 minutes to take a picture, so click, 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 click on your cell phones. Or if you have a scanner, that would be better. Scanning comes out better, like cam scanner or something like that. And then you have until 1:30 to submit the homework. But if you want to submit the homework early, you're allowed to submit the homework early. Okay. Then after that, we only have one last chapter per se, although it does include 4.9. But again, in my opinion, 4.9 belongs with all this. And then we have 3 weeks to do it. In fact, I've got it so that we might finish fairly early. I've got buffer days left over. Okay, so if we have here 4.9 to 5.4, including the Thanksgiving holiday, we should be able to finish with plenty of time. Okay, so tentatively the last exam is on Thursday, but we'll play it by ear. Maybe we can have it earlier or later, as the case may be. We'll see what happens. Maybe we can have some review time for the final. Speaking of the final, our final exam is on Wednesday, the 16th of December. So it's a little bit more than a month. And the time is 11:10 to 1:40. Okay, so how do I prepare for the final exam? You can just study off the old exams. The old exams are sufficient for the final exam. And you may have all the previous cheat sheets. So that means in theory, you can have 5 formula sheets for the final. I mean, you don't have to reinvent the wheel and start all over again. Just keep your formula sheet for the first test, second test, third test, fourth test, fifth test, and just keep them all for the final exam. And obviously for the final exam, there's no homework to turn in, so you don't have to worry about that. You just have the whole time to work on the final exam. So please note the schedule time is 11:10 to 1:40, so you have the entire time. Finals week, the schedule is all different. We don't meet our regular times, and check with your other teachers for their final exams. But our final is Wednesday the 16th. So I guess what would that be? The 14th? The week of the 14th through the 18th is finals week, so we don't have regular meetings. The only time we meet is for our final exams, Wednesday the 16th, and then we're done. So 11:10 to 1:40. Now, how many questions do I give on final exams? Well, I usually give about 10 questions, so maybe 15 or 20 would seem reasonable. Okay, 15, 20. And let's see, we're going to have 5 tests. So we have 5 tests, and that means what? Maybe 3 questions from every chapter test. If I give you 15, or if I give you 20 questions, then that would be 4 from each of the previous exams. Doesn't mean I'm giving the very same question. I might tweak it a little bit. But hey, maybe I'll give the very same question. Who knows? We'll see. Okay, so that's the final exam I need to mention. So Wednesday the 16th. So after Friday, December 11th, we don't meet Monday, we don't meet Tuesday, we meet Wednesday. And please notice the starting time is 11:10, not our usual 12:10. So if you join at 12:10, that's kind of late. You can still take the test, but you only have until till 1:40 to finish it for the final exam. Okay. All right, so I think that's all I want to say about that. Okay, so let me talk about the quiz, which is now too late to submit, of course. So quickly through the highlights. Domain is all real numbers. Okay, intercept is the origin, 0, 0, that's about it. No symmetry. If you replace f of x with f of negative x there means negative x e to the x. That's not the same as the original. That's not the opposite of the original. So there's no symmetry. Asymptotes and end behavior. So when x approaches infinity, you should treat this as x over e to the x. That's infinity over infinity. So by L'Hopital's root, LHR, L'Hopital's root, take the derivative of the top, derivative of the bottom. So derivative of the top is 1, derivative of the bottom is e to the x, and the limit as x approaches infinity of e to the x is 0. So when x approaches infinity, y approaches 0. When x approaches negative infinity, y approaches negative infinity. So if we plug in negative 1,000,000, I've got a large negative times a large positive, which is a large negative. Okay, so that means on this side, the graph goes like that, and the graph goes like that. Okay, so get the first derivative, derivative of x e to the negative x. So let's see, first function times the derivative of the second. Derivative of the second is e to the negative x times negative 1, chain rule, plus second function e to the x times the derivative of the first, which is 1. Factor out the e to the negative x, and you have negative x plus 1, or 1 minus x e to the negative x. I like this a little bit better. Double prime. First function times the derivative of the second, e to the negative x times negative 1, plus second function, e to the negative x, times the derivative of the first, which is negative 1. Factor out e to the negative x, and you have x minus 1 minus 1. Okay, negative 1 times 1 minus x is x minus 1. So x minus 2 e to the negative x. Set y prime equal to 0. So 1 minus x e to the negative x equals 0. E to the negative x can never be 0. So just look at 1 minus x. That gives me x equals 1. Plug in 1 comma e to the negative 1, or 1 comma 1 over e. Now, when you list your final answers, you should give exact values, which means leave e to the negative 1 as e to the negative 1, or you can write 1 over e. The 0.37 is only as a decimal approximation, but you should leave your answer as exact, which is either this one or this one. Okay, sign chart. Y prime is 1 minus x e to the negative x. E to the negative x is always positive, so the sign is completely determined by 1 minus x. Plug in 0, positive. Plug in 2, negative. So f is increasing from negative infinity to 1, decreasing from 1 to infinity. So I have a max at 1 comma 1 over e. Again, list it as this. Okay? Again, I grade quizzes a lot more leniently than I do exams. So if you don't do that for the exam, I may take off. Okay, so you probably notice on exams, I grade much more harshly than quizzes. Quizzes, you're getting ready for it. So if you leave it as a decimal, like 0.37 or 0.27, I might have said, okay, I'll let it go, but I might not let it go during exams. Okay, so you've been warned. Okay, so increases, max, decreases. Now, concavity, same thing. Set y double prime equal to 0. So x minus 2 e to the negative x equals 0. Again, e to the x cannot be 0. So only x minus 2 can be 0. X equals 2. 2 comma 2 e to the negative 2, or 2 comma 2 over e squared. You can write it like that or like that. But again, in your final answer, don't write it as 0.27. You can put 0.27 just approximately so you know where to plot everything. But leave it as either this or this. Okay, sign chart, x minus 2 e to negative x. Again, e to negative x is always positive. So plug in 0, negative. Okay, plug in 3, positive. So f is concave down from negative infinity to 2. F is concave up from 2 to infinity. So I do have a change in concavity, inflection point at 2 comma 2 over e squared. And there's the entire graph. Okay, so inflection point. So increases, goes through the origin, decreases, approaches the x-axis, concave down up until the inflection point of 2 comma 2 over e squared, concave up the rest of the way. Okay, so there we go. All right. And yes, the approximate locations were, what was that, 0.37 and 0.27. So yeah, that tells me that this is higher and this is lower. But when you write the final answer, write exact answers. These are the exact answers. Okay. All right, so I graded most of your quizzes already if you submitted it, quote unquote, early. If you submitted it today or recently or maybe even yesterday, I'm not sure I got to all of it, but I'll try to get the rest of them today. So if you just recently submitted it, no worries, I'll try to get to them by later today. Okay. All right, so new stuff. 4.8, something called Newton's method. So there's only 8 problems, 6, 7, 8, 11, and 16 all. I'll try to do maybe half of them, especially from the evens. Okay. So Newton's method. Again, the key idea that you need, I gave you some theory last time. We're just going to work them out now. So this is called Newton's method of approximation. So how do you approximate a solution? Okay, especially if you can't find it very easily. Okay, I gave you the theory last time, and here's the only formula that you need. It's on page 346. X of n plus 1 equals x of n minus f of xn divided by f prime of xn. Okay. Sometimes you can think of this as new and old. Okay, the x new is the x old minus f of x old divided by f prime of x old. Okay, so these are the old values. This is a new value. This is a recursive definition. Recursion. Some of you computer science people know of recursion. R-E-C-U-R-S-I-O-N. Recursion. Okay, you don't have to write that down. You don't have to even know about it for now, but you just keep plugging back into the same formula. So you're going to have a function. And by the way, we're finding zeros of a function. So you have to set the function equal to 0. If it's not equal to 0, you make it equal to 0. Okay, and I'll show you what I mean before you can start. So 6, 7, 8. Okay, 6, the function's already equal to 0. 7 and 8, function's already equal to 0. If it's not, you have to make it so. So 11 and 12 do not set equal to 0. I'll have to show you how you do that. 13 is already set equal to 0. 14 is already set equal to 0. Okay, 15 is not set equal to 0. So all you do is just throw everything on one side, set it equal to 0. So for instance, add x squared and subtract 4. Okay, and for 16, subtract the x. And I'll show you that. And you have to do likewise for 11 and 12. So I'll show you how to do that. So only 8 questions, and I'll show you about half of them all from even. Okay, so that's what's going to go on now. Okay, so hopefully it's not that big a deal. So you're given a function, okay, make it equal to 0. If it isn't equal to 0, set it equal to 0. So you have the function, you need to find its derivative, but that's usually no big deal. And then you start with a guess. Now, for 6, 7, and 8, they tell you your first guess. Nice. -1, 2, -1, or whatever. Okay. 11 and 12, they don't give you a guess. You have to make up a guess, although you can probably, guess intelligently, so to speak. And then 13 and 14, they give you a very small interval. So you can pick either endpoint or maybe the midpoint, right? You really can't guess too badly there. Then 15 and 16, they give you no guess at all. You have to make up your own guess. Okay. So how can I guess? Well, just pick something that's kind of close if possible. Right? But even if you don't guess too close, Newton's method will converge to the right answer anyway, which is very nice. Okay. All right, so let me get started on some of this. So number 6, here's a function, and they only want you to do it 3 times. So they give you x1, sorry, find x3, which means you're doing the approximation 2 times. The third approximation to the root. Give your answer to 4 decimal places. Okay, so the function is 2x cubed minus 3x squared plus 2 equals 0. It's already set equal to 0. If it isn't set equal to 0, you make it set equal to 0. And they tell you as a first guess to try -1. Okay, so let me show you the process for doing that now. This is very calculator dependent, so you want to do this on your own calculators. Of course, as usual, I will save time by telling you what I did before, but not actually spending time punching it in a calculator, except for later on when I have to show you how to do the answer key, I will have to demonstrate that. Okay, but for now, I won't punch it in my calculator. Take notes, make sure you can do it for yourself. Okay, so 2x cubed minus 3x squared plus 2 equals 0. Your first guess is -1. You say, how did they get that? Well, I don't know. We just guessed. It does seem reasonable that it would not be too, quote unquote, bad. I might have started with 1. Okay, I mean, what happens when you plug in 1? 2 minus 3 plus 2. Okay, that's pretty close. Okay, I'm guessing -1 is not too bad either. What do you get when you plug in -1? -2 minus 3 plus 2. To me, it's a little bit worse, but be that as it may, whatever. Okay, so here's the function. First thing you do is take the derivative. Okay, that's easy. 6x squared minus 6x. All right, so the way the formula goes is x2 is x1 minus function divided by derivative. Okay, so let me show you the actual. Okay, so you're given an x1. x2, n plus 1, is x1 minus function over derivative. So x2 is x1 minus function divided by derivative. And what am I plugging in? I'm plugging in the guess, which they told me was -1. Okay, so here we go. So x2 is -1 minus, by formula, the function. So plug in -1, right? 2 times -1 cubed, which is -1, minus 3 times -1 squared, which is 1, plus 2. Okay, that's the function, divided by the derivative. So I plug in -1 here now. So 6 times -1 squared is 1, minus 6 times -1. Okay, and that'll give me my next guess. Okay, so just crank it out. Let's see, that's -2 plus 2 is 0, minus 3. So the top is -3. The bottom is 6 minus a minus 6, 6 plus 6. Okay. By the way, you can see if I have 6 minus 6, this whole technique doesn't work. It all just falls apart, right? So Newton's method fails if the derivative is ever 0, as you can see here. So if you look back at the original formula, if the derivative is 0, you're stuck. Can't do it. Okay, but fortunately, you don't have to worry about that for any of the problems that we have. Okay, so clean this up. -3 divided by 12, -1 minus a minus or plus 1/4 is -3/4 or -0.75. Okay, so my x2, my next guess is -0.75. Then I do it again. Same thing. So x3 is x2 minus function divided by derivative. Okay, so see, it's an iterative process. You keep doing the same thing over and over and over. Okay, so x2 is x1 minus function divided by derivative. Okay, all right, now that I have x2, x3, the third guess is x2 minus function divided by derivative. And just keep going. x4 would be x3 minus function divided by derivative. And you just keep doing it over and over and over. You say, how do you know when to stop? Well, in this particular case, they told us to stop when you find x3. So that's nice. All right, just find x3 and then stop for 6, 7, and 8. Okay. In theory, though, I mentioned this to you last Friday, I think. Theoretically, when can you stop? Well, you get to stop if x of n plus 1 matches xn. Okay, so suppose I do this root. Okay, so the 7th time I did it, don't worry, you're not going to have to go 7 times. Okay, but let's say after the 7th time, the answer was 1.4. Then you did it again, it comes back to 1.4. Then you stop. Okay, the logic is if this is 1.4 and this is also 1.4, what should I subtract? 0. It's a fraction. When is a fraction equal to 0? When the top is 0. So f of x of n is 0. That's what I'm looking for. I'm looking for when does it touch the x-axis, i.e. when is f of xn equal to 0. Okay, so if you do this process and if you get, let's say, the 7th and 8th one match, you're done. You found the root. Okay, it may not show up until the 23rd and the 24th one finally match. Then you finally got it. Okay, again, this is theoretical. I won't make you go out that far. But if you have the answer key option, you might be willing to go that far because it's going to be a pretty easy process, frankly. Okay. Okay, so back to x3 is x2, negative 0.75, minus function divided by derivative. So I go back to the function, plug in the new guess, negative 0.75. Go back into the derivative, plug in negative 0.75. Okay, so sorry, I can't show you both at the same time, but it's 2x cubed minus 3x squared plus 2. Okay, 2 times negative 0.75 cubed minus 3 times negative 0.75 squared plus 2. All right, and then divided by the derivative, 6x squared minus 6x. Okay, so 6, plug in negative 0.75 squared minus 6 times parentheses negative 0.75. Okay, and just punch it out on your machine. The top came out to be 0.53125. The bottom came out to be 7.875. Okay, grind this all together, negative 0.6825. And for this particular problem, you can stop. That's all they want you to do. Find x3. Now, is it a good approximation? I don't know. You'd have to keep going, but I'm guessing it's pretty good. Okay. Problem's actually finished, but I'm going to dig a little deeper and maybe give some of you time to catch up. Let me actually plug this in to this and see how good it is. Okay, so negative 0.6825. Okay. Okay, so I'm stalling here, but I'm actually going to try to take that thing and plug it into 2x cubed minus 3x squared plus 2 and see how good it is. Okay, so 2 cubed minus 3 squared plus 2. Pretty good. I don't know if you can see it. It's negative 0.03. What are we looking for? 0. So we're already pretty good. If you can't see it, that's okay. It's negative 0.03. So I'm guessing if you were either very close or not that far away, it's probably off by only a little bit. So if I just use this as my answer, after just doing it 2 times, after just 2 tries, I already got negative 0.03, which is almost 0. Okay. All right, so that's the basic idea behind Newton's method. So concept again is you have your first guess. Your next guess is the old guess minus function divided by derivative. Plug it into the function, plug into the derivative. Okay. All right, that's that one. And number 8, please. X to the 7th plus 4 equals 0. And again, they tell you to guess negative 1. Okay. A side note here, which will help us in a future problem. So this is a little sidebar. If I actually were to quote unquote solve for x, well, x to the 7th is negative 4. X is the 7th root of negative 4. So what we're actually doing is playing computer and finding the 7th root of negative 4. This is the technique that you could use to find actual roots, square roots, cube roots, 7th roots, or whatever root you want, right? If I solve this algebraically, subtract 4, take the 7th root. So I'm looking for the 7th root of negative 4. So negative 1's a good guess. We doubt that that's exactly it, but we'll try that. All right, is it already set equal to 0? Yes, it is. Okay, so the function is x to the 7th plus 4. The derivative is 7x to the 6th. We're good. Right? So x2 is x1 minus function divided by derivative. Right? Directly plug in. X of n plus 1, x of n. x2, x1 minus function divided by derivative. So on top, I plug into the original function. What am I plugging in? Negative 1. Negative 1 to the 7th power, negative 1, plus 4 over 7 times negative 1 to the 6th power, right? So that's negative 1 plus 4 is 3. 7 times 1, negative 1 to the 6th power is 1, right? So 7. So negative 1 minus 3 sevenths, negative 10 sevenths. That's my x2. Then I do it again. So x3 is x2 minus function over derivative. Plug into the same functions, except now you're plugging in negative 10 sevenths, which is obviously more awkward. Okay, so the function is x to the 7th plus 4. So negative 10 sevenths to the 7th power plus 4 divided by 7x to the 6th. 7 parentheses, negative 10 sevenths to the 6th power. Okay, and just punch that in your calculator. Negative 1.5658. Okay, and it says it just stopped right there. And that's pretty much about it. Okay, so, and by the way, that's now how all of you can do this. Okay, so all of you, so if you have only a standard scientific calculator, you can do this. You won't be able to do what I'm about to show the rest of the class, unfortunately. Okay, so if you have the answer button, it's a huge advantage. Okay, so my calculator is down here. Okay, so all of you can do this right now. So if you understood that process, if you're happy with it, fine. I will be showing you now what happens if you happen to have the answer key, that it becomes very, very nice. Okay, so for those of you that only have a regular scientific calculator, sorry, you're a little bit out of luck right now, but you still can follow this. And I will construct the exam on Friday so that everybody can do it. So you're not going to be handicapped if you don't have the answer button. You just have to go a little bit slower. But I'll make it so that you can still finish on time, so to speak. Okay. Now, how to use something like 11 and 12. Okay, find the 8th root of 500. Use Newton's method to approximately give a number to 8 decimal places. Okay, on the exam, I won't have you go 8 decimal places. It actually is okay for those of you that have the answer button. But those of you that don't, that wouldn't be very fair. So I might just have you go to the 2nd decimal place, or maybe just say do it twice, right? Like these problems, right? Just find x2 and x3. I might say something like that. Okay, so how do I find the 8th root of 500 using Newton's method? Okay. So what you do first is the following. I'm going to make the problem almost like 4.8 number 8. Force it to look like x to the 7th plus 4 equals 0. So I'll show you how to do that. Okay, 8th root of 500, ignore the red temporarily. 8th root of 500 equals x. Okay. Raise both sides to the 8th power to make it nice. 500 equals x to the 8th, that's an equals there. Subtract 500, x to the 8th minus 500 equals 0. Okay, that's the way I want it to look. It's a nice polynomial. It looks like this now, right? X to the 7th plus 4 equals 0. So, oh, here we are. X to the 8th minus 500 equals 0. So my function is x to the 8th minus 500. And the derivative is 8x to the 7th. Okay. All right, now we have to talk about our first guess. I already showed it to you, so the cat's already out of the bag, so to speak. But suppose you don't know that, okay? X to the 8 equals 500. Well, it's got to be, and we're talking now about square root, so it's positive. Okay? What do you get when you plug in 1? 1. Okay. What do you get when you plug in 2? Well, 2 to the 8th power. 2 to the 8th power is 256. It's getting closer. It's actually closer than 3. What is 3 to the 8th power? 65, 61. Right? So 2 to the 8th, 256. 3 to the 8th, 65, 61. I'm looking for 500. It's got to be a little bit bigger than 2. All right? So my first guess is going to be 2. Okay. Now, for those of you that only have a regular calculator, you can work it out just like before. Okay. So your first guess would be 2. So you folks would be going 2 minus f of 2 divided by f prime of 2, right? Just the same thing as we did before. So again, our first guess is 2. 2 minus, okay, f of 2. So you plug in 2 to the function, which is x to the 8th minus 500, divided by f prime of 2, 8x to the 7th. And just keep repeating that process. Okay? All right, now, for those of you that do have the answer button, okay, I'll be addressing you folks. Okay? Now, you can write it down, or if you have your calculator, you can go ahead and try to follow along what I have. But I've written everything down for you anyway. Okay? So here's the way it would work. Your first guess is 2. First, punch in 2. Okay, so on my calculator, just hit 2 and nothing else. Sorry, I hit 2 and enter. So if you can see this, which I don't think you can, but just hit 2, enter. You start with your first guess. Okay. Right now, in your calculator, under answer, ANS, 2 is stored. Okay, the ANS button for graphing calculators or calculators like this stores the last entry. So whatever the last computation was goes into a special memory called answer. So right now it's 2. Okay. So we know the way it works. To get the new value, it's the old value minus f of old value divided by f prime of old value. Well, the old value is answer. Okay. So I'm going to put answer right there, and answer right there. I'll show you how to do that. So when you type it on your calculator, it goes like this. Answer, that's x1 right now, minus parentheses, function over derivative, right? So here's the function. Okay, don't type 2, type answer to the 8th power minus 500 divided by parentheses 8 times answer to the 7th power. Okay, so this time I'm not plugging in 2, okay, I'm plugging in answer. Okay, answer is already stored. So I took the time to hit the first value 2, it's 2. Okay, now watch me actually type this whole thing out. So I'm going to actually do it this time and waste time by doing it. But I'm going to hit answer literally minus parentheses. And by the way, you should always put parentheses here to avoid order of operations issues. Okay, parentheses, the numerator, divided by parentheses, the denominator. I'll show you exactly what mine looks like. So answer minus answer to the 8th power minus 500, parentheses, divided by parentheses, 8 answer to the 7th power. Okay, and assuming I didn't make any mistakes, if you can see that, try to hold this. That's exactly what I have there. Answer minus parentheses, answer to the 8th power minus 500 divided by 8 times answer to the 7th power. That is equivalent. It's equivalent to typing in 2 here, 2 here, and 2 here. So the calculator is going to go 2 minus 2 to the 8th minus 500 divided by 8 times 2 to the 7th. That's exactly what we were doing in the previous problems, right? In problem number, what was it, 6 and 8? That's exactly what I did. Okay, now I'll press enter. 2.2382, whatever, 2.2382, and so on. Okay, so that's what I have right now. Now, what's now stored in answer? This thing is stored in answer. Okay. This is the last command, which means I no longer have to type this in anymore. Okay, so watch what happens. Okay, I'm just going to keep hitting the enter key. That's the next guess. That's the next guess. That's the next guess. So in other words, you only have to type all that mess one time, because the calculator will continually update the answer button. Pretty neat, right? Okay. Now, for those of you that don't have this button, sorry, you folks have to type that whole thing out every single time, which is a little bit unfortunate. And I realize that, and I'll account for that, on the exam. Okay. But you can very quickly, come up with your next guesses. 2.238, and then 2.18, 2.174, and so on. Okay. And I'll just keep going a couple more. Okay, so after 5 or 6 tries, notice that they match. 2.17455927604, 2.17455927604, which happens very rapidly when you have the answer button. And now I can present this to however many digits that I want. Okay, again, the logic is, okay, what happens if 2 numbers are the same? Okay, these 2 numbers are the same. This is equal to this. Okay. If they're equal, that means I must be subtracting 0. If I subtract 0, a fraction is 0 when the top is 0. That means f of xn is 0. That's what I'm looking for. I'm looking for zeros of the solution. So I know I got it. So to a fairly good degree of accuracy, this is the 8th root of 500. Okay, so that's the way that works. And just for fun, let me try it out. So let me raise that thing to the 8th power and see what I get. So answer raised to the 8th power, 500. In fact, it gives it to me exactly 500. It's probably not exactly 500, but rounded to what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places. It's pretty close to 500. Okay, so that's how the answer key works. It's very, very convenient, as you can see. And I'll show you one more of those, and maybe that's pretty much about it. Now, I wasn't going to do for you 13 or 14, but they give you an interval. Okay. Explain how we know the given equation must have a root in the given interval. Okay. We did this before. This is something called the intermediate value theorem, IVT, intermediate value theorem. Okay. If one side is negative, the other side is positive, there's got to be a 0 there. Okay. So frankly, that's pretty much it. So plug in 2, plug in 3, they're opposite sign. 14, plug in 3, plug in 4, they're opposite sign. Okay. That's called the intermediate value theorem. We had that quite a while back. But if you just want to know what to do here, just plug in 3, plug in 4, one's positive, one's negative. For 13, plug in 2, plug in 3, one's positive, one's negative. Therefore, by the intermediate value theorem, somewhere in between, it has to be 0. That's all. Now, they don't tell you what to guess, but they might as well have told you. It's got to be between 3 and 4. So what's your first guess? You can pick 3. You can pick 4. Maybe I would pick 3.5. Right? Same thing here. 2.5. That's your first guess. All right. Now, 15, 16, they don't give you a first guess. So we have to make up our own. Use Newton's method to approximate the indicated root of the equation correct to 6 decimal places. Okay, the positive root, that means there must be a negative root. Positive root, 3 sine x equals x. Okay. 3 sine x equals x. I made a mistake. 3 sine x equals x. Okay, so the first thing you got to do is make it equal to 0. So 3 sine x minus x equals 0. Okay, so the function is 3 sine x minus x. By the way, this is in radians. Okay, and that reminds me, I better do it too. Make sure that you're in radian mode, because I just taught a previous class where they were in degrees. So I better change back to radian mode. Okay, so now I'm in radian mode. As you can see, if you can see it blinking there, it's now radians. And so I quit. I can get out of this. Okay, I need the derivative. Derivative of 3 sine x minus x, 3 cosine x minus 1. Okay, my first guess, well, what do you guess? You can pick 1, you can pick 2. Okay, so how did you come up with 2? Well, if I plug in 1, okay, or you can just experiment, you know, that would be okay. If I plug in 3, since there's a 3 here, that's probably going to be negative. Okay, so I decided to pick 2, but you could pick 1. Okay, so let's pretend I picked 2 as my first guess. All right, so I'm going to put 2. So remember, you have to punch into your calculator the first guess, 2. So now answer is stored as 2. So if I just hit second function answer, it should come back with 2. Okay, and now again, I type in this formula, put it on your cheat sheet, this thing, but instead of typing any real number, I'm going to put answer right here and here and here. So I'll be plugging in answer. So put your first guess, and then it's answer minus function over derivative. So 3 sine, don't type 2, type answer. 3 sine answer minus answer. Everywhere you see x, put answer. Divided by parentheses, 3 cosine answer minus 1. Okay, and we're just about out of time, but let me go ahead and show you that. So I'm going to go answer minus parentheses 3 sine answer, and I'll show it to you with parentheses. I hope that works. 3 sine answer minus answer, parentheses divided by, please notice if you're doing this all at once, you should put parentheses over the whole numerator and over the whole denominator. Okay, divided by parentheses 3 cosine of answer, parentheses minus 1 parentheses. Okay, so I think I typed in all of this exactly here. If you can see that, answer minus 3 sine answer minus answer, parentheses, divided by parentheses 3 cosine answer minus 1. If you can't read this, I got that there. Okay, press enter. 2.32 something. Okay, now the nice thing, what is stored in answer? This thing. What's the last operation? This. Okay, so instead of typing it all over, okay, this is my x2. Here's my x3. Press enter again. There's my x4. There's my x5. Real nice, right? So you only have to type it in once. For those of you with just a standard scientific calculator, sorry, it's a little bit longer. You have to actually grind it out each time. But I can get as many as I want. Oops, sorry. And yeah, I seem to have a match right here. So I would give my solution as 2.278863 rounded to 6 decimal places. So there we go, 2.278863. And that's about it. And there we go. Okay, I'm done, folks. Let me check the chat real quickly. Why did I set x1 equal to 2? Because I thought it was reasonable. You could have picked 1. Okay, and if you had to pick your own, you know, any choice would be reasonable. Although, you know, if you pick a million, that's probably too far. But since I saw the original function was 3 sine x equals x, right? I didn't have to go past 3, I suppose. Okay. So yeah, folks, I'm done, and I think I've actually finished the entire chapter. Okay, so I'll think about it. I might want to do a few of my own miscellaneous problems at the beginning. Otherwise, ask me questions tomorrow. Wednesday's a holiday. Ask me questions on Thursday, and the test is on Friday. Okay. All right, that'll do it for today, folks. So we'll see you tomorrow, and have a good day. Okay, bye, everyone.